so for part one of the measurements lab, we're going to be analyzing drops of water. We're actually going to be measuring or, quantifying the mass, the volume, and the density of a drop of water. Now, that's a pretty small quantity of water, and so using our instruments that we have available to us, we could measure the mass using valence, but it's only really going to change the mass probably by a couple decimal places in the second decimal place. And so our accuracy is pretty low because that's where our error already is in our measurement. And then if we try to measure the volume of a drop of water using our graduated cylinder, even using the 10 mil one, which reads to the second decimal place, a drop of water is only going to make a very small change in that volume, where we may not even be able to figure out the volume change. It's again going to be within our error, within our estimated digit. So what we'll do is we will measure the mass and the volume of several drops of water. And we'll do this for 5 trials. Now when I say several drops, I want to use at least enough drops to get a milliliter of water, fall somewhere between a mil and 2 mils. So probably around 30 to 40, maybe 50 max drops of water for each trial. So we're going to get started with this 10 mil grad cylinder, and what you should see is I've already got some water in there. Okay, so I have distilled water in there. I have some distilled water in this beaker with my dropper, okay, with just a standard kind of medicine dropper. And so what we'll do is I had already rinsed this, and then I put a portion at the bottom because then the grad cylinder's wet. We don't really have a true zero volume, but I wanted to get, the sides coated with anything that wants to kind of stick to the sides, so that reduces our error in our volume measurements. So this amount that's in there is going to be our starting. And so that's going to give us our initial mass and initial volume readings for trial 1. So I'll go ahead and put this on my balance. Now notice the balance is already zeroed. And so when we put this on there, we've got an initial mass of 36.91 grams. And so that's important to write down. Now, speaking of writing down this data, I did post a data sheet on Blackboard. You don't have to print that out and use it, but it gives you an idea of kind of how to organize the data, the things that you're going to be measuring, as well as the things you're going to be calculating. What we're measuring is the masses and volumes. We will also be counting drops, and so those 5 things, initial and final mass, initial final volume, and number of drops, is what you're going to be writing down during this video, and then you'll do calculations with those things. And then you'll enter all that information on Blackboard. So we have our initial mass. Now we need to get our initial volume reading. So we need to try to get to eye level with the meniscus. And so, let's see. Looks like we're between 1.9 and 2, maybe even right on 1.9. Yeah, I'd say we're right on the 1.9. So let's say our initial volume is 1.90. Okay, so our initial volume before we put the drops in for trial 1, 1.90 milliliters. Okay, because we have to read that to 2 decimal places. That second decimal place is our estimated. And then I'm going to add several drops. Okay, so I'm not going to count out loud. I will just add these hopefully quickly enough. like we've added enough. So, yeah, I've added 33 drops. So we're going to write down 33 drops for trial 1. And then we'll measure the mass, which our final mass for trial 1 is 38.04. And then, changed on me here. I moved. I guess I was a little impatient there. No, 38.04. We will leave it at that. Again, that second decimal place is the estimated, so sometimes it'll waver a little on there. Okay, so now the volume, final volume for trial 1 is, let's see, I gotta get kind of level, not level, there we go. Oh, that's pretty hard to see on the video, but it's definitely between 3 and 3.1, and say maybe about 3.03. I'm going to say 3.03 for our final volume of trial 1. Okay, now I know those volumes are a little tricky for you guys to see on the video. I have a little bit of an advantage looking at it without the camera. And so, but you do your best to try to look at it and understand the measurements, because you should know how to read a graduated cylinder. Okay, now those final measurements, that's our starting point for trial 2. We're not going to dump out the water and start over. So our final mass from trial 1 goes into our initial mass for trial 2, and our final volume for trial 1 goes into our initial volume for trial 2. So we've got those numbers, and then we need to continue to add drops. I've added enough. I added 37 drops. So trial 2, 37 drops. Now, what you need to realize is it doesn't matter that I've added a different number of drops. The density, which is kind of our final goal, or one of the goals, I guess, it doesn't change by the number of drops, okay? Our other goal is to kind of figure out how much per drop, what's the mass per drop, what's the volume per drop, or how many drops there are in a mil, or how many drops there are in a gram, and that doesn't change if we measured it based on a different quantity of drops, okay? To some extent, the more the better. Okay, so we can measure our final mass for trial 2, and it's 39.44. And then we can get our final volume for trial 2. And let's see. Too low. Yeah, mine's still too low. Okay, let's see. That should be about level. We're between 4.4 and 4.5. Actually, really close to 4.4. I'd say 4.41. I'll say 4.41 for our final volume. Okay. And then those final values again go to our initial for trial 3. So we have our initial mass and we have our initial volume. So we need to add more drops for trial 3. We're at 35. Okay, so 35 drops for trial 3. And the mass is 40.79. And then, let's see, the volume. Between 6.8 and 6.9, very close to 6.8. Actually, I think it's right on the 6.8. So we say 6.80. Or no, hold on. Let me go back to that. I'm focused on the line above. It's not 6. It's between 5.8 and 5.9, or it's actually at the 5.8. Gotta be careful reading those scales. I almost messed it all up. So 5.80 is our final volume. Okay. So we got our final mass, final volume for trial 3 goes to trial 4. And then we're going to add again more drops. Got 36 drops, and so again the mass for our trial 4 with 36 drops is 42.03 for the final mass, and then our final volume. Let's see. Should be about level there. And it looks like we're a hair above 7. Yeah, we looks like maybe 7.02. Again, this is a little tricky to see with the camera. That volume should be about 7.02 milliliters for the final volume for trial 4. And again, we'll move those final masses and final volumes in for the initial for trial 5. And then we'll do some more drops. So, last trial, trial 5. Okay, that's 33 drops. Okay, 33 drops for trial 5, and final mass for trial 5 is 43.18 grams. And let's see, final volume for trial 5. Okay, let's get this level. Maybe we're a little low here. Yeah, no, we're a little high. Sorry. There we go. Very close to 8.2, but I would say we're a little bit above. So I'd say something like 8.22. So 8.22 milliliters for our final reading for trial 5. Okay, so now we have all of the data we need to collect in the lab for this part of the experiment. Now, what we want to calculate is the mass of the drops that we added for each trial, the volume of the drops added for each trial. And to do that, you take the final mass minus the initial, and the final volume minus the initial volume. And each of those are the masses of those total number of drops. Then we can take that mass and volume, divide, and get the density of that portion of water that we added. Once we do that, we want to actually scale it down to per drop. And so the mass per drop and volume per drop, you would take the mass, the total mass of the drops added that we just calculated from final minus initial, and divide by the number of drops. And so that's where those number of drops for each trial is important. So for trial 1, whatever the mass is, you divide it by 33. And for trial 2, whatever the subtraction of final minus initial mass is, you divide by 37, and so on. And you would do the same for the volume. And so that's going to tell you the mass of a drop for each trial, the volume of a drop for each trial, or at least on average. And then you want the density per drop. Now, for that, all you need to do is take the mass, divide by the volume. So you just calculated the mass per drop, the volume per drop, you divide, you get the density. Now, you should be able to compare that to the density of all the drops and understand a little bit something more about density. You should realize that density is an intensive property, not an extensive property. So there should be something a little unusual about those values. Then you are asked to average all of that stuff for the trials. So you're going to get averages for the per drop values. And then what you're going to do for the mass and the volume part is you're going to invert those. Now, the reason I ask you to do that is that you can get a better perspective on what a gram is and what a milliliter is, because those are units we use a lot in chemistry. Okay, so what you're going to have is an average volume per drop, so the milliliters per drop, which is going to be very small because a drop is very small. It is smaller than a milliliter. And so what you'll do is you'll take 1 divided by that value. When you do that, you should get something larger than 1. Several drops are in a milliliter. And so that's what you'll be solving for. You'll also do the same for your mass. You'll have how many grams a drop is, and you're going to take 1 divided by that, and that's going to tell you how many drops are in a gram. And so that hopefully should give you a little better perspective of those units that we will be using a lot, since everyone's very familiar with water and you know you have some perspective on what a drop of water is. And so then all of that stuff, once you have the collected data from the video and you have all those values calculated, that information you're going to input to the lab assignment on Blackboard, along with the data for part 2, and then you will be answering questions about each part.